Okay, so what we are doing today is classes. In object-oriented programming, classes are very important. Okay, uh, class is a collection of similar entities. You can see that it's a collection like furniture is a class. Trees also in trees also classification is there. Animal classification is there, and if you see books in a library, they are all classified. They are kept in the same shelf. Like physics will be in physics, IT books will be in the section of IT, and then again segregated or classified. So segregation or classification is collection basically of similar entities. Okay, so when we have similar entities together, we call it a class. So Python is an object-oriented language, but it is not a pure object-oriented language. Okay, so why we call it? Because it can run on the command prompt or even without any class, without any functions. So if we can have something like shell programming and all in Python, so Python can be programmed without using classes, functions, anything. It can be direct also, but classes actually gives it a flexibility of being an object-oriented language. And like Java is a pure object-oriented language, right? Because it cannot start without a class. We have C++ also, that is another object-oriented language, but we can have again in C++ a program without a class name. But in Python, without a class, we cannot actually start anything. Sorry, in Java, you cannot start anything. In Python, you can definitely, yeah. Okay, so we have the classes are we can have create the class using the class keyword, and then we have to give the attributes, that is name of the class, and what all we want with that. Okay, we can have an object. Now the interesting part with the class is classes to access an entity. Now whatever there in is there in the class, like if you're talking about furniture, we're talking about table as the entity. So if you have to access it, we need an object for it. Okay, without an object, you cannot access a class entity of the class, you can say. Now, suppose I'll just give you an example of a library. That's my favorite example also. We have classified books in a library. Now, if I want to access or I want to issue, I want to get a book from the library, what I need is a library card. Without a card or without the access, I cannot actually use the library. I cannot get into any books, any sections. So the entities are not visible to me unless I have a card. Similarly, to access entities of a class, we need an object. So this your library card can be treated as an object to access the class entities. So whatever there is in the class, we can call it an entity for the timing. Let's not be very restrictive. We can call it an entity. Okay. But there are other definitions and all we can call few things. But anyway, we'll get into that later. We have to see practically how it works. So let's see the syntax first, how class is defined and why I'm telling you about the class. We'll work on that. Okay, so as I said, it's a collection of similar entities. To access a class, we need an object, and this is how it goes. Statement, the code, -1, -2, so on. It goes to -n. This is actually the syntax only, and how we are going to use it, I'll show you. Okay, so with an example, we'll understand first, and then we'll go ahead and see other things in it, right? So we can have a simple class and see how we are going to access it. So let's have one class example. Okay, we can give you have to use a keyword class. Okay, so class my sorry class, and I give some variable n is equal to. Okay, now if I run this, what happens? Nothing will happen. We'll run it. It takes time for the when we run for the first time. Okay, class my class n is equal to 5. Now I cannot access it, right? To access it, what I need is an object. Okay, so we'll create an object. As I said earlier, to access any entity of a class, we need an object. Let's say we take obj is equal to new, or we can we don't need this keyword here. We can have my class. Now to access it, sorry, we need obj dot in. Something like this. Let me run it now. I'll explain it again. Fine. Now what happened is, suppose obj is your library card. Now this is the book you want. Suppose n is the book you want. To get this book, I have to use object. That is my library card or my ID. Okay. So this is object, and this is the entity. So obj dot n, you can access any entity in a class. Okay, so let's have one more example. Let's have some. Now n is equal to 6, n is equal to 8, and some I can give the same name, n plus 8. Okay, something like this you have. We can give the parameters and all that we'll talk, see, but simply like this. Now I want to access this, so obj is equal to sum with a round bracket. The round bracket is required. uh, okay, I won't have some here, I'll have some here. This will make more sense, but how I'm going to get it will be little different. Obj dot n plus obj dot n. Okay, now and the entity, object and the entity, adding it up and print sum. That's one. Okay, fine. So you can access the variables outside the class using an object to the class. Okay, so this is just a simple example. This is not how we implement classes in Python. We can have the functions also inside the class, and why I want to put it in a class is very simple. When we have big projects, okay, this class gives you reusability thing, like power to reuse the functions inside it or the class inside it. Suppose I have this class, I put it in the global environment, and we have a project with let's say 100 functions. Some big programs would be having 100 functions or 50 functions, whatever functions. Now I have something like sum, which is to be repeated every time. So I don't have to code it again and again. What I can do it, I can simply access this class, and I can use the variables, and I can do whatever I want. I can access the the entire class, whatever the functions are inside it, or whatever the variables I have defined it. So just by using the object, I can use it. So it gives you the flexibility to reuse. Now the question comes, like this can be done using the functions also. Why we need the class? So class is actually classifying what you are doing. So within class, it is more defined. Okay, it is more classified. Okay, okay, this class is for doing what. So in a big program, it is very very important. In a big project, it is very very important to have proper definitions, a proper classification of codes. Otherwise you will not be able to find them later, how to access it, where to go, where to find. If I simply put 100 codes, you won't be able to find out what is doing what, which code is doing what. If I classify that into, let's say, 10 classes, now I know, okay, this particular class is for computing, this particular class is for uh, you know visualization, or displaying, or printing, something like that. Okay. So once it is in a class, I can access it, and it gives you more security also. Without an object, I don't know which class is. With an object, and we don't know what entities are inside the class. Only a programmer would be knowing that. And we have options to secure your class also. Okay, so you can secure the class, and people won't be able to access that. It is something like abstraction. These are object oriented, has some principles, and on based on that, we have classes. Okay, an object oriented programming actually has four pillars: abstraction, encapsulation, inheritance, and polymorphism. Okay, I've not written it here. I'll put it in the notes, what an object oriented is and what all these four things are, but you can understand it for the time being. Okay, or I can put it in the notebook itself. So an object oriented language has four pillars. One is abstraction, second is encapsulation, third is inheritance, and fourth is polymorphism. Okay, they are not in sequence, I'm just telling you randomly. Okay, now understand what is abstraction. Abstraction is hiding something which is not important from the user. Let's see with an example. Now suppose you are running a car. What is happening inside, you don't know, like how the engine is functioning, how the petrol is going, how the fuel injection is working and all, right? You don't know, and you're not bothered also. Why you should be bothered about uh, how the functions, how the engine is working, or how the every how the wheels are rotating, when you just have to drive it. Okay, you are only concerned when you are designing it, or when you want to get more output from it, or you want to get it repaired, there's some issues, then only you'll be opening the bonnet and see what is going inside it. Okay, so this is basically abstraction, abstracting something which is not important from the user, right? So we have in object oriented programming, abstraction important thing. And if you relate it with human, because in AI, artificial intelligence, everything has come from human, right? Now, if I relate it with AI, abstraction to human being, then we are the biggest example of abstraction. It is very interesting to note that we just use our body. We have a body, but we do not know what is going inside it. We can't see it unless we take an MRI or X-ray or something, or sonography, or we get it done, then only we can see inside our body. We don't know what is there inside it, or whether it is working fine or not, right? So this is abstraction. Your skin actually abstracts everything inside it. Okay, so you can't access any part of your body just like that. You can't even see it. And why you can't see it? Because suppose we have a transparent body. Suppose we have a transparent body. Okay, we can see through our body what is happening. Now, suppose something goes wrong or something is not working, you see that, oh, fine, my blood is not going properly, it is pumping slowly. What will you do? You'll just open yourself and try to repair yourself, or maybe someone else, right? And you'll just mess up everything and just end your life. So it's not required. Why should you know what is going inside the body, how the food is going inside it? Okay, so how the things are happening inside your body is not required. So what is happening inside a class is not required. Suppose if it is not required, then it can be abstracted. That is called abstraction. Okay. Now the smaller brother is your encapsulation. Encapsulation is hiding the local area. Okay, or protecting the local area. I'll relate it with the uh, human being again first, and then we'll see how it works. Now, suppose you have to go outside and it is raining. What will you do? You will take an umbrella, and this umbrella protects you from the rain. If you are going out in the sun, again you can take an umbrella, or you can put a sunscreen lotion to protect your skin, right? So if you're protecting the local area, that is called encapsulation. Encapsulating the thing, protecting the local area from damages. Now, in programming, abstraction is carried out using the variables only. The entity is the data types of the variables, and private, public, like we have seen in the global, non-global, something like that. Okay, so you can have your variables protected by making them private. Nobody can access, but the programmer or the coder or the person who has access to the particular module, only that person can do that, use it. So if it is a private one, so it is not accessible by all. So we have something like that. So you can create uh, your environment in such a way that you can create or you can encapsulate. So normally it is variables which are encapsulated so that not nobody can actually access them. Now how we do it is a different thing. I will come to that, and we'll see that whether we can do it in Python or not. Okay, but this is the basic of your object oriented language. So two things we have seen: abstraction and encapsulation. Now comes the third one, that is inheritance. We all know what is inheritance. We inherit or carry forward the properties of our father, forefathers, our parents, okay, grandparents, and all genes we carry, okay, or the nature we are carrying. So we inherit. Even not, it's not only that you are inheriting the property of your parents or grandparents. It's actually inheriting everything, your nature, your blood type sometimes also, and genes definitely. So you're inheriting that. So inheritance in a code would be something like one class is inheriting the properties of another class. So you have something like a nested. It's not a nested class, but there are two classes and one can clone the other. Then we can call it inheritance in that case, or in that case, with one object I can access both the classes. Otherwise you cannot actually. But if you are inheriting, then you can do that also, right? Directly you cannot, but we have to inherit it. Okay, so inheritance is possible, but we have to see whether it is possible in Python or not. We'll see that, but first we have to see the examples and understand what the four pillars of OOPS are. So three pillars: abstraction, inheritance, encapsulation. Three we have seen. The sequence can be. And then comes the fourth one, that is polymorphism. I'm telling the four basics, okay? You can divide further. But let's have the fourth one, that is polymorphism. Poly means more than one. FISM means activities. So if you have more than one activity going on at the same time, we call it polymorphism. Okay. Now, we human, our biggest example, as everything in object oriented has come from human examples only. We people have this capability or a gift of the nature that we can do more than one activity at the same time, right? Like in online classes, you must have observed it and seen it also, that people are having their earphones, earplugs, or headphones, and then they're doing something else also, right? So one day I was teaching, and I could hear in the background some utensils, and I asked the student what happened. She said that I'm cooking also. So this happens that she was sincere, but she's a brilliant student. So even if she's listening, she's actually listening properly. So I know that she's grabbing everything. So she said, then I have to prepare the food, otherwise we won't have the food on time. So you can carry on with your class. I'm listening to you and doing my work also. And sometimes people can concentrate better this way. Okay, so that is the capability or the capacity of a person doing one more than one thing at the same time. You must have seen people walking on the road using the mobile and walking also, although they may bang into some pillars or something or someone also. But at the same time, they're doing a lot of work. So we human can do a lot of work at the same time. Now, if I relate it with my programs, then we have a biggest example of a game. You must have seen that a lot of activities happen at the same time in a game. A person is moving also, firing also, jumping also, doing whatnot. Right? Now, we achieve that definitely, and it looks like that everything is working simultaneously, but a program cannot, a system cannot. We have parallel processing, more than one process can be run parallelly, but there is a nanosecond of delay which we do not see. Because of the speed of the processor, the instructions are pipelined and passed on, and they just happen so quickly that we can't even see that there was a delay. Okay, so you can see that the polymorphism, more than one activity can happen at the same time, and that actually normally we achieve by using parallel processing. And in parallel processing in Python, when we are using, we'll see that how we can do it. But I can tell you one example. We have tensors in Python, and tensor arrays. I'm not sure I've shown you that or not, but we have tensors in Python. Okay, and that gives you capability of parallel processing. If we are using, there are two things we have. One, the CPU, that is the central processing unit. Okay, that is your computer definitely, and there's one GPU, graphical processing unit. Now, when we are working on CPU, we are having a simple programming, normal. It's not parallel, one to one. But when you are using a graphical processing unit, GPU, then we have the capabilities of parallel processing. One process, more than one process at the same time. So if you have a gaming laptop, the one I have is a gaming laptop. The one I'm using right now is a gaming laptop. I don't play any game. I need this because of my complicated codes in Python and other languages like MATLAB or Java. So I need this because without this, I won't be able to access parallel processing. Okay. So this parallel processing gaming laptop, you would see that there would be a graphic card in that. Now, this graphic card actually, what happens? It gives you the capability of a parallel processing. It will help you to process the things simultaneously. Okay, more than one activity at the same time. So your graphic card, like the one I use and the one which is supported by Python is NVIDIA. NVIDIA graphic card. We have others also, but in Python we or in tensors we need a NVIDIA graphic card. That is the card which is supported directly by tensors. So that is the preferred card. So I have to get always have to get a system which should have NVIDIA, although it would be little costly because other graphic cards are cheaper, but this would be little costly. Not much, but yes, definitely it will be little costly. But this gives me the capability of parallel processing, which I can use in my codings, and it gives me the capability to have better gaming experience also. If I want to play games, like I have inbuilt Xbox also, right? I have never used it, okay, but it is there. And this shows that it has the capability of parallel processing. More than one process at the same time can be carried out. Okay, so that is what your polymorphism is all about. More than one activity at the same time. So four things, four pillars of object-oriented programming: abstraction, encapsulation, inheritance, and polymorphism. So these are the four pillars. This is what object-oriented coding is all about. But we have to see how they can be implemented, how beneficial it could be later. But for now, we will see how we are going to have classes in Python. So this one we have seen already. So those who just joined or joined late, so we start a class by giving the keyword class and the name of the class, whichever class I want. And to access a class, I need an object. So I have to create an object. In Python, it is very easy. I can say obj is equal to my class with a round bracket. If I am using Java, then I will have to use obj, my class obj is equal to new my class. So that is a different syntax. This is a different simple syntax, nothing like new or any keyword required. So you can directly use this object. And now to access the entity, I need the object and the variable name or the entity name. So in this example, what we have done is we have a class sum with the n is equal to 6, n is equal to 8. An object, we create an object. Okay. So let me write it. Create an object. Okay. Then access the entities and then just print the sum. So this is how we can use a class. But let's see some more examples and see how well we can do or what we can actually do with classes. And we'll see also that we can have abstraction or not. Okay. Now we have the function here with the classes that is called init function. That is very important actually. So we'll be seeing that also and what it is going to do. We'll see that. Namespace and all we discussed earlier, but and given the text, I don't think I have taken it. But anyway, that is the environment where we work normally. That is the namespace. So let's see the functions now. So I'll just take it and then I'll put the theoretical part there. But init function, initialization function, it is basically we'll be using that. Theory I'll put later. So let me put it here and then I'll put it. This is the function, initialization function or init function, but it is not used like that. Okay, it is like I have to put it in quotes only, then I can use it. Okay, I have to put it in. Otherwise, underscore will go. Now I can see this. Initialization function or init function, that is the function we use within a class. Okay, So suppose I was using a class and some, this is my class, and my initialization first is def init, then we have self, and let's say a and e, that is the parameters we have. Self is for current, this is what we give. Oh, sorry. Okay, now to access it, now in Java we have a keyword called this. Okay, we don't define it, but in Python we have to give self. Okay, so we are giving self here, a and b, that is you have to access the variables and whatever I'm passing to it. Now what I'm doing is self dot a is equal to a and self dot b is equal to b. This is what I have to do, and I'll show you what happens now. Outside the function I can have the sum, and I can simply call it now s is equal to sum, and in 12 you can pass it directly. uh, Sum is equal to, sorry, object I have created, sum is equal to, this is creating an object with parameters. I'll just write it, create an object with parameters. Sum is s, now s dot a plus s dot, sorry, okay, and now I can print the sum. It's as simple as that. Let's run it. There is some problem here. Yeah. Create an object. This is fine. I've used some only. There's some issue. I left something. Did I? No, I did not. It is not giving me the reason. Some takes no arguments. Oh, okay. There is no argument. That is what it is saying. But let me put it properly. Put another one. It is taking, because it just tells me that this won't have any arguments. It is taking. You have to give this one init with two underscores. There are two underscores. This is one. Actually, I had given one. There are two underscores. That is why it was giving an error. Let me show you. Okay. This is what I had given. Now, when I run it, it will give me an error. So let me correct it. I'll use the same function with two underscores. Okay. Now, if I run it, it will work because it is going to find the initialization function. Okay. So that is why I created that, and you can see here easily that the function it accesses first is the init function automatically by default. So init function is the default function, even if I don't give it like we have given here. We have not given any function, so I can access it directly also. But it is always better to put the things in brackets and sorry, in proper classes, functions, to access them, to give it more flexibility, more reusability. This way you can get use it again also, simply by changing the values of the parameters. I can just pass on, because you can't give the parameters just like that. Okay, so you need something. You don't have an option to give the parameters directly on in the class. So what you need is a initialization function that tells me that okay, you have to initialize the class. You are initializing the class with certain variables. So that is what init function is all about. We need that, and can access it. Anyway, so init with two underscores. Otherwise, it will give you an error. It will not be able to detect that it is your initialization function which the class has to access. Like we have seen in main also, init main or find main. So we were using two underscores there also. Okay. Let's have another one. Complicated. We'll have some class complex numbers. We can have. We'll have a complex number. Again, define two underscores init, two underscores self, and then we can give a real and imaginary part because in complex numbers this is what we have. There's something sorry, that's fine. Yeah, that's fine. So self dot r is equal to real, self dot I is equal to imaginary. You can use the same variable name or different variable name self, and then we have a function again define. We have another function. It has to be the same way. My function, and in this also I'm passing self. Now what happens? I can print. And I can simply call it. I don't need a nested function here. I can have the real and the imaginary part. I've already extracted that. I just have to get them. So I need an object obj is equal to my complex and sorry complex my complex, and I can give the numbers. Let's say 4.5 comma minus 3.2, something like this. I can create, and you can print obj dot real and print obj dot dictionary. Okay. So let's understand this again. We have a class my complex. In this we have the initialization function which has self in it, real and the imaginary part. Now real and imaginary, that is if 4.5 it is going to take, and minus 3.2 will go in real and image. This is the parameter we are passing. Now self will give me the flexibility to create my variables on the run, and also to have local variables where I can have the local variables like self dot r is equal to real and self dot I is equal to image. So the real part and the imaginary part is stored get stored there. We are not extracting; we are just passing the real and the imaginary part. Now I can put obj dot r. I can access self dot r with obj dot r, and this as I. Sorry, it's not image. It's I. So you can access it like this, and we can run. So variables in the initialization function can be defined like using self keyword. You can see this. So the results definitely will be there. Okay. Now let's have the object methods. Now we we have already created the objects, but let's see more. We have some nested functions also, and in that we can do. Okay. So let's have the class we had MySum, and we can have something like this. I already have it, so I'm just pasting it. Now, we have a class MySum. If the function initializes function self AB, the cell dot A is equal to A, cell dot B is equal to B. You can actually change this to anything. Okay, the variable you want. And we have another function which is my function, which is self. Then print sum is equal to self dot A plus self dot B. Now what we do is S is equal to my sum 56, 76 or whatever I want, 66. Let's have increase. We can have input also. Okay, and S is equal to my function. Just call the function now. We are not accessing the variables. But this is something like encapsulating that. I'm only worried about the sum. I'm not worried about what is happening inside it. This is similar to what we have it in encapsulation. So we are encapsulating it. We are not affecting the class. We are just encapsulating the local variables. It is similar to that. Not definitely saying that it is encapsulation. So it is addition of it is 68 and 86. You can have something like this, or I can pass the variables also. Let me copy it. Variable I'll take v1 equal to int input. This would give you more flexibility because now you don't have fixed values. Okay. So let's see if it can run. Fine. No issues. You can have more flexibility with the numbers entered by the user. Otherwise, you'll have always the fixed results. For testing purpose, is fine, but practical purpose, you should ask the user to enter the numbers for the calculations. Okay, so self parameters, or let's see what is that. That is what we have used, self parameters. So it refers to the current instance of a class. It is not necessary to name it self. Okay, name itself. Sorry, name it as self. As self. Okay, self. It was speaking like. Okay, no, it's fine. So we'll have another class now. I can just simply put it the one I had, and I can instead of self, I can put it. Sorry, copy it from here. And instead of self, I can have myself. Now I can put myself, and I can put myself, and this will again will be myself. This will again be myself. Only thing is, whatever you use, you have to get the same thing. Fine. So you can have something like this. Self, myself, or whatever you want to have. Have variables like this. This is not limited to self keyword like we have in Python. This keyword which is limited, you cannot change it, but in Python you can have anything inside it. Okay. So either you use this or you use myself, it doesn't make any difference. Okay. Now The usability issue is very simple now. And, always call and just run it. Anyway, the function is there. Your my function is there, so I can even now just use it directly. Something like this. You can create an object also. I created. Yes. Okay. I would have a object instead of that. This is more meaningful. Sorry. If I run it again. You can access now anywhere, anytime. So that is reusability thing with your classes. And now you can delete the object, and that is the beauty of Python. You can delete the objects also, or object properties also. You won't be deleting an object. You just have to delete the object properties. So if I say del obj dot, we have what? Even v2, I think I had. I have to see what is inside a. But if I try to call that, let's see, it will give me an error. It will say my sum object has no attribute a. Okay, so it will throw an error because we have deleted that particular entity, right? So my sum object has no attribute. There's no attribute a because we have already deleted the thing. So that is one interesting thing with Python. You can actually delete them also. So we have the class variables and the instance variables. Uh, it's okay. And just try to finish it fast. So I'm just copying. Okay. Now you have a class dog. Breed is canine. That is class shared by all instances. This is a global variable, you can say. Then this variable is accessible by all. Now define functions. Now initialization function self and nm. Nm is the name. Now self dot nm is equal to nm. Whatever I'm going to pass on. So this is an instance variable. This is a class variable. This is a class variable. This is an instant or the local variable. Okay, within a function instance variable. Now a is equal to dog. We are calling this with the body. We print the breed. Now a dot breed, what it is going to give. Then instance variable, class variable. Then we just change the dog to Tuffy. That is the name. You can see class variable canine and instance variable is buddy. That is what we passed on. And again, with the other example, it is canine and Tuffy. B dot breed and B dot n in M. B is equal to A was a dog, and in this case B, that is another object. We can have obj1, obj2. Let's make it like that. Otherwise, it is going to confuse. There's nothing to do with the variable name. It is the object basically. Okay, so obj2 dot breed again. You can see that it is breed is canine, and what we pass is stuff. So two examples. So instance variable is inside a function, and class variable is out, is immediately after the name of the class. That is within the class. So we have instance variables. Now let's see with another example. But I'll have to change the names to objects. They have to be more meaningful. There's nothing to ABC. I normally don't give it, but somehow I used it last time. So I'm just renaming that. I'm not using the same name of the object just to avoid overlapping. Okay, I don't want to miss my earlier name of the variables. Okay, objects rather. obj1 is giving some error. There is no obj1. Okay, so we have obj and obj2. Now we have this a list, empty list. Let me put it. We have empty list, then we have cell nm, lr, and self.nm. Then we have another function that is add trick self.trick self.trick.append trick. That is we are adding it into this list. Okay. Now we are creating an object, then we are printing it, printing again on the variable class variable and instance variable with different uh, things we have. So initially when we run it, it is an empty list. Okay, obj.trick, then instant variable body, that is okay, then class variable again, that is empty, so it is empty. Then we have instance variable, that is stuffy, but now we were appending that. Okay, so we have a obj.add trick shorthand, and obj to add trick rollover. We have called the function and we are now running it, and we can see that it is now shake hand. Sorry, it is not sharp. It is shake hand and rollover, which is appended, and we are using object obj only. We're not using obj2. If I use it, add this trick here. It's still the same. So whether I use obj or obj2 won't make any difference because it has already appended. Okay, so you can use it like this. So what we are doing is we are appending, and once we run it like this, it will keep on adding, and we have the list. It will keep on adding, and we can have the list now. You can use a loop also and put the things in there. Okay, so let's have another example. Something like this, and I'll copy it from here. What we have done is we have a class dog, and then initialization function. We have self.name is equal to name. Then we are creating the empty list inside now. Okay, inside initialization. Now add trick is again self and trick. And we are just appending it. We have to keep in mind whatever we are giving here should be repeated here. Like if I give myself, then it should be myself. It all should be myself. Should be myself. Okay. calling the thing again with the dog buddy. Then we are printing the class variable. Then we are calling the second object with dog Duffy and printing that. Then we call append the we pass two names shake hand and roller, which is to be appended, and we are just printing obj dot trick, and we'll print more now. One more. Let's print both and see. There's some issue here. Obj dot trick is not there. Trick is not there. It is tricks. Okay. I'll make it trick. Otherwise, I'll have to change everywhere. It did not show me error because it was using the other one also. Okay. This is append trick. So we don't have now tricks. There are two actually, so that's why I used two. But anyway, you have to use S. Oh, no, don't have to. You can see that up till now it's the same thing. Now obj.trick will be empty. There is no class variable, so it is not appended automatically. Like in this case, it was appended globally. So any the you have this thing obj.trick was having the data, but in this case it is a local variable which is empty. So second object will be giving you, because we are appending using the second object. You can see that there's nothing obj1, only one, which doesn't help in appending anything. So local and global variable, you have seen how they may vary. Okay, so we have something like this. We have some more examples, the same thing. Yeah. Let's have the random remarks. So we have some class warehouse. Warehouse. Now we have what is the purpose? Purpose is equal to storage. And then the region. East, west, north, south, north. We can have north. Whatever. Object obj is equal to warehouse. You can print region. And we can have another one. Obj1 is equal to warehouse. And then in this we have We created another one. Now I want to change that region. obj1 dot region is equal to let's say west. Change it. Now let's print and see. See that? Now we can run it. Storage north and then storage and west. This is now the west. Now we have functions defined outside the class. Like this. I'll have to give some time for you to digest it also. So I'll just give you some time now. But let me give this last example. You can give some break so that you can understand. I'll have to change. We have defined a function. This is outside, okay? This is not inside the class. And then we have a class and the function also and returning also. I'll have to change the object. I'll make it obj and just this. We'll run it and we can see the difference. What happens? You can access the function without name of the object. You don't have an object actually for it, and you can call it directly. You can see that I'm calling obj.my function. You have my function here, calling it here in the class. This function is called inside the class, and then you can have the self return welcome. This thing, so you can see that the x is below x, y, z, and obj.x and obj.xyz. That is what we are printing. So this is also welcome. This is also welcome. We're just putting 4, 6. Obj is small. We're creating an object. 4, 6 we're passing. And what we are doing is just printing 4. That is A, the first variable. Return minimum. That is minimum 4 and 5. I can just put something like 78 and 96. If I return it, the minimum will be 78. It will be returned. Okay, or we can have 9. It is like this. Minimum is now 6. So 6 will be returned. So outside also, you can define the function and then you can call it again. Right? So we should take a small break and so that you can just go through it. I'll copy it and share the link with you so that you can digest it a little and then we can just finish off with the remaining part. Okay, so let me 1 minute just save it. Just copy the link. You have access to the root, so you should not have any issues. Classes are simple, nothing much. I've shared the link here and I'll share it in the group also. Okay, so let me share it in the group. It's not, it's frozen. Anyway, I'll just put it in the Teams. I can share it later also, so not a big deal. I'll just put it here and in the new conversation I'll put it, although it is there already. You can just have a look. Okay, so have a look at what we did so that, and just not have a look, just practice, type yourself Don't copy paste. Try to create errors and see. Just try to do something differently and see what happens. A few things left which I'm going to cover and finish it today. And for now, we can take a small break of 20 minutes and we can continue so that we can have a look at the things, right? Just take a small break so that you can go through. I have already shared the link. It is there in the chat also. It is there in Teams also. Just have a look. We'll continue. We'll stop the recording. It's not required.